For today's software engineering interview, we'd like you to design the backend for something like Tinder. Sure, I'm only going to focus on the matchmaking aspect of Tinder, so we're going to assume we have things like user profiles already in place. The matchmaking service is going to be hosted using ECS, and we're going to put that behind an application load balancer to distribute traffic. Makes sense, but why do you have 3 different databases? An important part of the user experience is quick swiping and instant matches, so we're going to load all the current swipe and match data into Redis. Now, we're also going to keep a log of old swiping and match data into Postgres, which we can use for analytics and curating the algorithm. The last and final database we're going to use is a graph database, which will help us actually craft the relationships between different people on the app. Can you go into a little bit more detail about how the graph database is going to be used? Okay, imagine these are all different users of our app. The solid lines represent users that have matched with each other. Say we have user A who matches with user B. If user B matches with user C, then we know that user A might like user D and user E. Using a graph database, this is a very quick query. We can also do things like quickly finding users that have a lot of matches based on how many edges are leaving the different nodes. Feels like a little overkill given we could just count the user's matches in the SQL table. Anyways, what are we going to do when a user actually gets a match? Okay, you bring up a good point. In order to enable an event-driven architecture, we'll integrate with Amazon's simple notification service here. When a user gets a match, we can instantly notify something like the chat service or any service which would push a notification to the user to tell them that they have a new match.